February 14th, 1944, 6:47 a.m., Boeing Plant 2, Seattle, Washington. The B-29 Superfortress hanging in the assembly bay looks like an aluminum cathedral. 70 tons of riveted dreams suspended on scaffolding 3 stories high. Mechanics swarm over its wings like ants on a carcass, each man a specialist, each rivet placed with the precision of a jeweller setting diamonds. William Knudsen stands at the edge of the factory floor, hands clasped behind his back, watching. He's 59 years old, built like a Danish farmhand, which is exactly what his father was before bringing the family to America. His suit is wrinkled from the overnight train from Washington, D.C. His eyes are not. The plant supervisor approaches, chest puffed with pride. Mr. Knudsen, welcome to the future of American air power. Each Superfortress represents over 10,000 man-hours of the finest aircraft engineering in the world. We're currently producing 16 aircraft per month, which I'm proud to say is... You're building them wrong. The supervisor's mouth hangs open mid-sentence. Around them, the cacophony of the factory continues, pneumatic riveters hammering like machine gun fire, the screech of metal on metal, men shouting measurements across the cavernous space. 200 workers on this one aircraft alone. Masters of their craft, every single one. Excuse me? Knudsen points to a mechanic 30 feet up, hand-fitting a complex bracket to the fuselage. The man is eyeballing the alignment, making micro-adjustments, consulting a schematic rolled out on the wing. It's artistry. It's also taking 17 minutes. How many of those brackets are you installing per aircraft? 47, sir. Each one has to be precisely matched to... Are they identical? Well, functionally yes, but the mounting points vary slightly, so each technician has to... Then you're building them like furniture. Knudsen's voice isn't cruel. It's matter of fact, which somehow makes it worse. Tell me something. How many B-29s does General Arnold need to firebomb Tokyo? The Air Force requisition is for 4,000 aircraft by, at your current rate, how long will that take? The supervisor's face goes pale as his mind does the math. 16 planes per month. 4,000 needed. 20 years. The war would be over, won or lost, long before they finished the order. Knudsen starts walking down the assembly line. His shoes click on the concrete floor, each step deliberate. Workers glance at him, then return to their tasks. They've seen inspectors before, generals, senators, men who tour factories and make speeches about American ingenuity before climbing back into their staff cars. But Knudsen isn't looking at the aircraft, he's looking at the men. Where did you find your workforce? He asks. We recruited master aircraft mechanics from across the country. Curtis Wright, Douglas, Lockheed. These men have 15-20 years of experience each. They understand the tolerances required for, and when one of them is sick, or quits, or gets drafted. We have to train a replacement. It typically takes 6 to 8 months before they're productive on the Superfortress line. The complexity of the systems requires... Knudsen stops, turns, looks the supervisor dead in the eye. You're telling me that if I walked onto this factory floor right now and asked any one of these men to switch stations, they couldn't do it? Not without extensive retraining, no. The wing assembly team can't work on tail sections. The engine mechanics don't touch the pressurization systems. We have 47 specialized teams, each responsible for 47 bottlenecks. The supervisor bristles. Mr. Knudsen, with all due respect, these are the most sophisticated aircraft ever built. The pressurized cabin alone requires sealing techniques that didn't exist 2 years ago. The remote-controlled gun turrets, the radar bombing systems, How many cars did General Motors produce last year? The question comes out of nowhere. The supervisor blinks. I'm not sure. Several 100,000? 4 million. Knudsen lets that number hang in the air. 4 million vehicles, each one with an engine, a transmission, electrical systems, hydraulics. How do you think we did that? Cars aren't bombers, sir. No. Knudsen turns back to the suspended B-29, its aluminum skin gleaming under the factory lights. Cars are harder. The supervisor makes a sound like he's been punched. Around them, men are still working, still riveting, still measuring, still installing brackets one at a time with craftsman's pride. Each aircraft a masterpiece. Each masterpiece taking 10,000 hours to complete, while American boys die in the Pacific waiting for air support that's being built too slowly to matter. Knudsen pulls a small notebook from his pocket, starts writing. The supervisor leans over trying to read, but the handwriting is too small, too fast. What are you doing? Counting waste. Waste? Mr. Knudsen, we're running at 92% efficiency according to... You're running at 8% efficiency. Knudsen doesn't look up from his notebook. And if we don't fix it in the next 6 months, we're going to lose this war. The factory noise seems to fade. Somewhere in the distance, a shift whistle blows. Workers begin climbing down from the aircraft, heading to break, to coffee, to cigarettes. The B-29 hangs there half-born, a metal promise of destruction that won't arrive in time. The supervisor's voice is quiet now, almost afraid. What did you see that I didn't? Knudsen closes his notebook, looks at the man, and for the first time since arriving he smiles. I saw a factory that's never built an airplane. 3 hours earlier, 3:52 a.m. Knudsen's private rail car approaching Seattle. William Knudsen doesn't sleep much anymore, hasn't since December 7th, 1941, when the phone rang in his Detroit office and a shaking voice told him about Pearl Harbor. He'd been president of General Motors then, the largest manufacturing corporation in human history. By December 8th, he'd resigned. President Roosevelt had called it patriotic. Knudsen called it obvious. Now he sits in the pre-dawn darkness, watching Washington State scroll past his window, reviewing production reports by lamplight. The numbers are staggering. America is outproducing the Axis powers in tanks, trucks, rifles, artillery shells. The arsenal of democracy, they call it. Knudsen helped build that arsenal, helped transform Ford's River Rouge plant into a B-24 Liberator factory, helped Chrysler start making Sherman tanks, helped 1,000 small manufacturers retool from making washing machines to making shell casings. But the B-29 is different. The Boeing reports spread across his desk tell a story of magnificent engineering and catastrophic inefficiency. Each Superfortress is a revolution. Pressurized cabin, remote gun turrets, radar bombing systems, range enough to reach Tokyo from bases in China or the Marianas. It's the aircraft that will end the war, if they can build enough of them. Current production, 16 per month across all facilities. Required production, 300 per month by 1945. The math doesn't work, can't work, not the way Boeing is building them. Knudsen picks up a photograph from the file. It shows a B-29 assembly bay. Dozens of men clustered around a single aircraft, each one a specialist, each one irreplaceable. It's how you build a cathedral, or a custom automobile for a millionaire. It's not how you build 4,000 warplanes. He thinks about the Willow Run plant in Michigan, Henry Ford's masterpiece, a factory building one B-24 Liberator bomber every 63 minutes at peak production. Assembly line techniques adapted from automobile manufacturing, interchangeable parts, parallel sub-assemblies, workers who could be trained in weeks, not months. Ford had been criticized for it. Aircraft engineers called it crude. Artisans complained the planes lacked the hand-fitted precision of traditional construction. They were right, technically. Willow Run Liberators had more manufacturing variation than hand-built consolidated aircraft. They also existed in sufficient quantities to actually fight the war. The train begins to slow. Seattle's industrial district emerges from the morning fog, warehouses, rail yards, and in the distance the massive Boeing facilities. Knudsen gathers his reports, straightens his tie, and does something he's done 1,000 times before. Prepares to tell proud men that everything they know is wrong. 9:23 a.m. Boeing Plant 2 conference room. 12 of Boeing's senior engineers sit around a mahogany table. These are not foolish men. They've designed the most advanced aircraft in aviation history. They've solved problems that didn't have names 6 months ago. They've worked 18-hour days, 7 days a week, to give America the weapon that will burn Japan's war machine to ash. And now a car manufacturer is going to lecture them. Knudsen can feel the resentment in the room. It's thick enough to cut. He doesn't blame them. He'd feel the same way if some aircraft engineer walked into GM and started redesigning the Chevrolet production line. But Knudsen isn't here to redesign aircraft. He's here to redesign how they're made. Gentlemen, he begins, standing at the head of the table, I spent this morning on your factory floor. Beautiful work. Each B-29 is a masterpiece. I've never seen such precision engineering. The engineers relax slightly. Perhaps this won't be so bad. You're also losing us the war. The room goes rigid. Knudsen pulls out a piece of chalk, walks to the blackboard, starts writing numbers. Current production rate 16 aircraft per month. Man-hours per aircraft 10,000. Total monthly man-hours 160,000. He underlines that number. Now, General Arnold has requested delivery of 4,000 B-29s by the end of 1945. At your current rate, you'll deliver 288 aircraft. You're short by 3,712 bombers. An engineer near the end of the table, grey-haired, wire-rimmed glasses, speaks up. Mr. Knudsen, we're aware of the production targets. We're working to hire more skilled mechanics, expand the facilities, add additional shifts. You can't hire your way out of this. I beg your pardon? Knudsen turns from the blackboard. There aren't enough skilled aircraft mechanics in America to meet your production targets. Even if there were, training them takes 8 months per man. You don't have 8 months. You probably don't have 8 weeks before the Joint Chiefs start asking why Boeing can't deliver. The grey-haired engineer's face flushes red. These aren't automobiles, Mr. Knudsen. A B-29 has 55,000 individual parts. The pressurization system alone requires how many parts in a Chevrolet? That's not relevant. 3,200 parts, and we assemble one every 2 minutes. Knudsen lets that sink in. You're telling me your aircraft is 17 times more complex. Fine. That means you should be building one every 34 minutes, not one every 20 days. That's absurd! The tolerances alone are achievable with proper fixturing and interchangeable components. Knudsen starts drawing on the blackboard, a flowchart, sub-assemblies, parallel production lines. You're building each aircraft like a custom order, every mechanic solving the same problems from scratch, every bracket hand-fitted, every wire harness routed individually. It's craftsmanship. It's also insanity. Another engineer speaks up, younger, defensive. Mr. Knudsen, aircraft manufacturing isn't like automobile production. We can't just stamp out wings on a press and bolt them together. The aerodynamic loads, the structural requirements. Douglas is doing it. Silence. Douglas Aircraft in Long Beach. They're building C-47 transport planes using semi-automated assembly techniques, training new workers in 3 weeks instead of 8 months. Their production rate has tripled in 6 months. Knudsen taps the blackboard, and the C-47s fly just fine. The grey-haired engineer stands. The C-47 is a transport. The B-29 is a strategic bomber with systems that didn't exist 2 years ago. You cannot compare. Then let me compare something else. Knudsen's voice cuts through the room like a blade. At your current production rate, how long until you deliver 4,000 aircraft? The engineer's mouth works silently. 20 years, 9 months. The war will be over. We'll either have won without your bombers or lost waiting for them. Knudsen walks back to the table, places both hands flat on the mahogany surface, leans forward. Gentlemen, I'm not here to insult your engineering. The B-29 is magnificent, but if we can't build them fast enough, they might as well not exist. And right now, they don't. The room is silent except for the distant sound of rivet guns echoing from the factory floor. Men building masterpieces, too slowly, too carefully, too late. The plant supervisor, who's been silent until now, finally speaks. What are you proposing? Knudsen straightens, picks up his chalk again. I'm proposing we stop building aircraft and start manufacturing them. February 14th, 1944. 11:17 a.m. Boeing factory floor. Knudsen stands in front of a partially assembled B-29 wing section. 23 men work on it, each performing specialized tasks. A master riveter here, a hydraulic systems specialist there, an electrical technician routing wire harnesses through channels that were hand-measured and hand-cut. He's watching one man in particular, mid-40s, greying hair, hands moving with the unconscious precision of 20 years' experience. The man is installing a series of fuel line connections, each one requiring him to measure, cut, bend, fit, test, and secure the tubing. It's taking him 43 minutes per connection. There are 18 connections in this section. Knudsen pulls out a stopwatch, times the process, makes notes. The plant supervisor stands beside him, arms crossed. That's Eddie Moreau, best fuel systems man on the West Coast. Worked on the Boeing 314 Clipper, the B-17, now the B-29. He can route fuel lines in configurations that would take a normal mechanic days to figure out. What happens if Eddie gets sick? We have a backup technician, Johnson. He's been training under Eddie for 4 months. 4 months to learn to install fuel lines? To learn to install them correctly in a B-29, yes. The pressurization differential means every connection has to be. What if both Eddie and Johnson are sick? The supervisor's jaw tightens. Then that aircraft sits until one of them returns. Knudsen makes another note, walks to the next station. Here, 3 men are hand-fitting aluminum skin panels to the wing's leading edge. Each panel is slightly different. Each one requires trimming, drilling, countersinking. The men work with the concentration of surgeons. How long to fit one panel? Approximately 2 hours per panel. The leading edge is critical for aerodynamics, so are the panels identical on every aircraft? Theoretically. But there's always some variation in the underlying structure, so each panel has to be adjusted to. Why is there variation in the underlying structure? The supervisor blinks. Because each rib is hand-measured and hand-cut to specification. Minor differences are inevitable when... No, Knudsen turns to face him. Minor differences are inevitable when you don't use jigs. We use jigs for the critical components. You need jigs for every component. Knudsen starts walking again, faster now, his mind cataloguing problems like a machine. Every rib identical, every panel identical, every bracket, every bolt hole, every wire routing path. Make them once, make them correctly, then make 10,000 exact copies. Mr. Knudsen, that would require retooling our entire production process. The cost alone. What's the cost of losing the war? They stop at the fuselage assembly station. Here, the complexity multiplies. The pressurized cabin section requires sealing techniques so precise that each seam is tested individually for leaks. Knudsen watches a technician apply sealant compound by hand, smoothing it with a specialized tool, checking with a pressure gauge, reapplying where needed. It's meticulous, it's artistry, it's taking forever. How many men do you have qualified to seal the pressure cabin? 14. We're training 6 more, but the failure rate is high. Many can't master the technique. Because it's being taught as a technique instead of a process. Knudsen points at the sealant compound. What's the specification for application thickness? Between 0.015 and 0.025 inches. Too thin and it leaks. Too thick and it adds weight and interferes with panel alignment. And your technicians achieve this by feel? By experience and testing? Yes. Knudsen pulls out his notebook, sketches something quickly, shows it to the supervisor. Notched applicator, set depth, apply compound in 1 pass, train a man in an hour instead of a month. The supervisor stares at the sketch. It's so simple it feels like cheating. But the compound consistency varies with temperature. The applicator wouldn't. Then control the temperature, climate-controlled workspace, consistent materials, eliminate the variables. Knudsen is drawing faster now, ideas flowing. You're asking men to compensate for environmental factors that shouldn't exist in the first place. They continue through the factory. At each station, Knudsen sees the same pattern. Skilled craftsmen solving problems manually that should be solved systematically. Artisans compensating for variations that shouldn't exist. Master technicians whose expertise is being wasted on repetitive tasks that could be standardized. At the electrical systems bay, Knudsen stops for a full 10 minutes. Watches a technician route hundreds of individual wires through the fuselage, referring constantly to a schematic, marking each wire with identification tags, testing continuity at each connection point. How long does the complete wire harness take? 46 hours for the main fuselage harness, another 20 for the wings. The complexity of the radar systems and remote turret controls requires... Do you pre-assemble any of the harnesses? Some of the simpler sub-harnesses, yes. But the main runs have to be done in the aircraft because you're routing them after the structure is built. Knudsen's voice has an edge now, not anger, urgency. You're building from the outside in, structure first, systems second, it's backwards. How else would you build the systems first? Knudsen gestures at the suspended aircraft. Pre-assemble complete wire harnesses on benches, pre-route hydraulic lines, pre-install pneumatic systems, build them as modules, test them as modules, then install complete modules into the airframe in minutes instead of hours. The supervisor is shaking his head. That would require completely redesigning the installation sequence. The structural assembly would have to be designed around the systems instead of forcing systems into the structure. Yes. Knudsen looks at him. How long do you think it took me to figure out interchangeable engines for automobiles? I don't. 3 years. Know what happened during those 3 years? We kept building cars the old way, because I knew if we waited until the new way was perfect, we'd never start. So we implemented it in stages, one improvement at a time, each improvement paying for the next. Knudsen pulls out his pocket watch. They've been walking the factory floor for 3 hours. He's filled 17 pages of his notebook with observations, sketches, calculations. The supervisor looks exhausted, defensive, maybe a little terrified. I'm not criticizing your people, Knudsen says, his voice softer now. Every man on this floor is giving everything he has, but you're asking them to solve an impossible problem. You're trying to scale craftsmanship. It doesn't scale. It can't scale. The only thing that scales is process. They walk back toward the conference room, past the master craftsmen, past the artisans, past men who take pride in hand-fitting each component, who can tell by sound whether a rivet is properly set, who know their aircraft like a violin maker knows wood. Men who are magnificent at a method that will lose the war. At the conference room door, Knudsen stops, turns to the supervisor. I need 3 things. Access to your complete engineering specifications. A team of your best production engineers, not your best craftsmen, your best engineers. And 6 months. 6 months to do what? To triple your production rate and cut man-hours by 70%. The supervisor's laugh is involuntary, disbelieving. Mr. Knudsen, that's impossible. We'd have to rebuild the entire... Yes, the cost would be less than building 3 times as many factories. Knudsen opens the conference room door. Inside, the senior engineers are waiting, their faces a mixture of curiosity and hostility. Gentlemen, we have work to do. You're going to teach me how to build a B-29, and I'm going to teach you how to manufacture 5,000 of them. The grey-haired engineer from earlier speaks up. Mr. Knudsen, with all due respect, you've been here for 6 hours. We've been building these aircraft for 2 years. What makes you think I've been building things for 40 years? Knudsen walks to the head of the table. And I've learned one thing that matters more than engineering brilliance or manufacturing expertise or dedication. He pauses, looks at each man in turn. Speed wins wars, not perfection. Speed. He picks up the chalk. Now, let's figure out how to get fast. 1944. 6:34 a.m. Boeing Engineering Department. The conference room table is covered in blueprints. Not the clean, archival copies kept in fireproof cabinets, but working drawings, marked up with grease pencil, stained with coffee, corners dog-eared from 1,000 consultations on the factory floor. Each blueprint represents hundreds of hours of engineering. Each one is about to be torn apart. Knudsen hasn't left the Boeing facility in 4 days. He's sleeping 3 hours a night on a cot in an unused office, eating sandwiches brought by secretaries who've started calling him the Viking behind his back, partly for his Danish accent, partly for the way he's pillaging their sacred processes. This morning, he's assembled a team. Not the senior engineers who built the B-29. They're still too attached to their creation, too invested in proving that everything they did was necessary. Instead, he's pulled in the younger production engineers, the ones who work the factory floor, the ones who've watched master craftsmen perform miracles and wondered why miracles were necessary. 8 men sit around the table, tired, skeptical, curious. Knudsen drops a thick folder in the centre. Production analysis. Every station, every task, every man-hour on the current B-29 line. He opens it. 10,247 man-hours per aircraft. We're going to cut that to 3,000. A production engineer named Morrison, 32, MIT graduate, actually served on a B-17 crew before a flak injury sent him home, speaks first. Sir, we've been trying to optimize the process for 18 months. We've already eliminated thousands of man-hours from the original prototype builds. I don't see how... You've been optimizing craftsmanship. We're going to eliminate it. The room goes quiet. Knudsen pulls out the first blueprint, the wing assembly. Current process: master craftsmen hand-fit each rib to the main spar. Time per rib, 47 minutes. Ribs per wing, 36. Total time per wing set, 56 hours. He looks up. Why? Morrison frowns. Because each rib has to be precisely aligned for aerodynamic integrity. The tolerances are... I didn't ask about tolerances. I asked why each rib requires 47 minutes of hand-fitting. Because the mounting points on the main spar have slight variations from the nominal specification. Each rib has to be adjusted to match the actual position of... Stop! Knudsen underlined something on the blueprint. You just told me the problem. The main spar has variations. Why? Well, it's hand-measured and hand-cut from aluminum extrusions, so minor differences are unacceptable. Knudsen pulls out another drawing, a fixture design he sketched at 2 a.m. Precision jig. Cut every main spar identically. If the jig is correct, every spar is correct. If every spar is correct, every rib fits without adjustment. Hand-fitting time, 0. Morrison stares at the drawing. But the jig would cost $8,000 to build. Know how much it costs to pay skilled craftsmen to hand-fit ribs for 56 hours per aircraft. Knudsen does the math on the blackboard. At current wages and production targets, $47 million over the life of the program. The jig pays for itself on the first aircraft. Another engineer, Carson Older, worked at Douglas before Boeing, leans forward. Mr. Knudsen, even if we build perfect jigs for every component, we still have the problem of skilled labour. The men installing those components need to understand the systems, need to be able to troubleshoot, need experience with... No, Knudsen's voice is firm. They need to be able to follow instructions, that's all. The room erupts. 3 engineers talking at once, voices rising. The B-29 isn't a Chevrolet. You can't just hand a worker a wrench and expect them to assemble the most complex aircraft ever built. The systems interact in ways that require understanding, not just mechanical skill. This isn't an assembly line job, it's... Knudsen waits, lets them vent. When the noise dies down, he speaks quietly. How long did it take to train you gentlemen as engineers? 4 years of university, then. And how long did it take to train the master craftsmen currently building B-29s? Most have 15 to 20 years of experience in aircraft manufacturing. March 17th, 1944. 7:18 a.m. Boeing Experimental Assembly Bay. 2 identical spaces, 2 identical sets of materials, 2 very different approaches to building a B-29 wing section. On the left side of the bay, Boeing's master craftsmen work with the confidence of experience. 5 men, average age 47, combined experience of 93 years in aircraft manufacturing. They move with practiced efficiency, measuring, fitting, adjusting. No wasted motion. The quiet competence of men who've built hundreds of wings and could probably do it blindfolded. On the right side, a different scene. 12 workers, average age 26. A former grocery store manager, 2 ex-farmhands, a laid-off schoolteacher, a mechanic who worked on tractors before the war, 3 women who'd never held a rivet gun until 3 weeks ago, and leading them, Morrison, clipboard in hand, looking like a man who's bet his career on an impossible theory. Knudsen stands in the centre, stopwatch in one hand, notebook in the other. Behind him, a gallery of observers, senior Boeing engineers, arms crossed, waiting for vindication. Army Air Force procurement officers sent from Washington to witness this experiment. And in the back, quiet but unmissable, 2 men in suits from the War Production Board. The stakes are clear. If this works, Boeing retools everything. If it fails, Knudsen goes home and they continue building 16 aircraft per month while American boys die waiting for air support. The senior engineer, his name is Whitmore, Knudsen learned, steps forward. Mr. Knudsen, before we begin, I want to state for the record that this test, while interesting, cannot possibly capture the full complexity of B-29 production. A single wing section under laboratory conditions is vastly different from... Agreed, Knudsen interrupts. That's why we're testing everything that matters. Speed, quality, defect rates, and most importantly, replicability. If your craftsmen build a perfect wing that only they can build, we've learned nothing useful. Whitmore's jaw tightens. Very well. Shall we begin? Knudsen raises his hand. Both teams look up. Gentlemen, ladies, build me a wing. Clock starts now. The craftsmen on the left begin immediately. No instructions needed. The lead technician, a weathered man named Kowalski who's been building aircraft since the Douglas Cloudster, picks up the main spar, runs his hand along its length, feeling for imperfections. His fingers find a slight deviation, invisible to the eye. He makes a mark with grease pencil, files it smooth in 30 seconds. Muscle memory, expertise. On the right, Morrison's team consults the instruction manual Knudsen forced them to create. Step 1. Remove main spar from fixture. Check identification number against work order. The school teacher, her name is Ruth, and she's got steady hands from years of threading sewing machines, lifts the spar. It's heavy. She struggles for a moment, then another worker helps. They check the ID number. It matches. They place it in the assembly jig exactly as the instruction shows, with a photograph to confirm correct placement. 30 seconds behind already. An hour in, the gap widens. The craftsmen are on their 6th rib installation, each one fitted perfectly, adjusted by eye and experience. Kowalski barely needs to measure anymore. He knows. Morrison's team is on their 3rd rib, but they're accelerating. The first rib took 20 minutes. Reading instructions, finding tools, figuring out the jig. The second took 12. The third takes 8. They're learning. Not from years of experience, but from a process that captured years of experience and made it transferable. Knudsen watches the grocery store manager, a man named Pete, who'd never seen an aircraft up close before February, install a rib. He follows the instructions exactly. Places the rib in the alignment fixture. The fixture, designed by Carson based on Kowalski's hand-fitting technique, ensures the rib seats at precisely the correct angle. Pete picks up the pneumatic riveter. The instruction manual shows him exactly where to place it, with colour-coded dots on the fixture matching colour-coded dots on the rivet gun placement guide. He pulls the trigger. The rivet sets perfectly. He moves to the next position. Another perfect rivet. No measuring, no adjusting. No years of experience required, just a process smart enough to compensate for an inexperienced worker. 2 hours in, something shifts. The craftsmen are still ahead on total ribs installed, 11-7. But Morrison's team is moving faster. The farmhands have figured out a rhythm. One positions the rib while another prepares the riveter. The schoolteacher marks completed steps on the instruction sheet, keeping everyone synchronized. They've formed an assembly line within the assembly process. The craftsmen work as individuals, each a master of their domain. Beautiful to watch. Slower than it needs to be. Whitmore notices. Leans over to whisper to another senior engineer. They're conferring, pointing. The craftsmen are doing everything right. So why are they being caught? 3 hours in, Morrison's team pulls even on rib count. 12 ribs installed on each side. But Morrison's ribs are identical. Measured by laser alignment tools Carson brought in, every angle matches to within 0.001 inches. The craftsman's ribs are perfect too, but each one is slightly different. Hand-fitted to compensate for variations in the main spar, individually perfect, collectively variable. Knudsen makes a note, doesn't say anything, lets the data accumulate. By hour 4, Morrison's team pulls ahead. 15 ribs to 14, then 17-15. The acceleration continues because they're not thinking anymore. They're executing. The instructions tell them where to place each component. The fixtures ensure it goes in correctly. The colour-coded tools prevent mistakes. All the knowledge Kowalski carries in his head has been externalized into a system that anyone can follow. Kowalski himself is sweating now, not from effort, from pressure. He can feel the eyes on him. The senior engineers expecting him to prove that craft matters, that experience matters, that you can't replace 40 years of skill with a jig and an instruction manual. He works faster, makes a small mistake. Nothing serious, just places a rib slightly out of alignment, catches it immediately, adjusts, costs him 3 minutes. The kind of mistake experience prevents, except when experience is being watched and judged and maybe, for the first time in 40 years, found wanting. Hour 6. Morrison's team has 28 ribs installed. The craftsmen have 23. But more importantly, Morrison's team is still accelerating. Ruth, the schoolteacher, just installed a rib in 4 minutes flat. This morning she'd never installed a rib in her life. Now she's working at 80% the speed of a master craftsman, and she's been doing it for 6 hours, not 6 weeks. Whitmore is no longer whispering, he's staring. The mathematics are undeniable. If inexperienced workers can reach 80% efficiency in 3 weeks, and you can field 3 times as many workers because you don't need 15 years of experience, the multiplication isn't linear, it's exponential. Hour 8. Morrison's team completes the wing section. 36 ribs, all installed, all aligned, all riveted. They step back, exhausted. Pete has blisters on his hands. Ruth's arms are shaking from fatigue, but they're grinning. They've just built part of a B-29 Superfortress. Yesterday that would have been impossible. The craftsmen finish 47 minutes later. Kowalski sets down his tools with the careful precision of a man who knows he's just witnessed something terrible. Not the death of his craft. He's too good for that. But the death of his craft's necessity. Knudsen approaches both wing sections, pulls out a laser measuring device, checks each rib alignment. On the craftsman's wing, variations of 0.002 to 0.008 inches, individually perfect, collectively variable. On Morrison's wing, variations of 0.001 to 0.0015 inches, more consistent. Not because the workers are better, but because the process is. He pulls out a pressure testing rig, mounts it to each wing section, applies stress loads equivalent to 4G combat maneuvers. Both wings perform identically. The craftsman's wing is not stronger. The assembly line wing is not weaker. They are functionally identical, except one took 5 master craftsmen 8.8 hours to build. The other took 12 inexperienced workers 8.0 hours. Knudsen does the math on a blackboard where everyone can see. Current Boeing method, 8.8 man-hours times 5 skilled workers equals 44 man-hours per wing section. New method, 8.0 man-hours times 12 workers equals 96 man-hours per wing section. Whitmore jumps on that. So your method uses twice the man-hours. How is that? I'm not finished. Knudsen continues writing. Training time for skilled worker, minimum 5 years. Availability of skilled workers in America, approximately 2,400 qualified for B-29 work. Training time for assembly line worker, 3 weeks. Availability of trainable workers, essentially unlimited. He underlines the next part. Current method, maximum production capacity, constrained by skilled labor availability. Maximum monthly output with all available skilled workers, approximately 40 aircraft. New method, maximum production capacity, constrained only by facility space and materials, maximum monthly output with proper tooling and workforce. He writes the number. 300 aircraft. The room is silent except for the distant sound of rivet guns from the main factory floor. Men still building aircraft the old way. Slowly, beautifully, insufficiently. One of the War Production Board observers steps forward. Mr. Knudsen, if we retool Boeing's facilities for this method, what's your projection for implementation timeline? 6 months to full implementation, 3 months to see significant improvement. And the cost? Approximately $4.2 million for jigs, fixtures, tooling, and facility modifications. That seems expensive. It is. Know what's more expensive? Knudsen points at the craftsman's wing. Building aircraft so slowly that we lose the war. The invasion of Japan, if we do it without air superiority because we couldn't build enough B-29s, will cost 50,000 American lives. Minimum. How much is that worth? Nobody answers. Whitmore walks to Morrison's wing section, runs his hand along the ribs. Perfect spacing, perfect alignment, perfect rivets, built by people who 3 weeks ago didn't know the difference between a rib and a spar. It's not craftsmanship, he says quietly. No, Knudsen agrees. It's manufacturing, and manufacturing is how we win. April 3rd, 1944, 5:42 a.m. Boeing Plant 2, main assembly floor. The night shift is ending when Knudsen arrives. He hasn't been back to the main production floor since the test. Spent the last 2 weeks in engineering conferences, procurement meetings, arguing with accountants who think $4.2 million is too much, and generals who think 6 months is too long. But today, the real work begins. The factory floor has been divided. Half continues producing B-29s the traditional way. Boeing can't afford to stop deliveries entirely while retooling. The other half stands empty. scaffolding removed, workbenches cleared, 200 master craftsmen transferred to other facilities or other aircraft. Their expertise suddenly less valuable than their seniority. Some went willingly, others didn't. Yesterday, Kowalski turned in his badge. 43 years in aircraft manufacturing, and he's choosing retirement over learning to work from instruction manuals like a first-year apprentice. Knudsen doesn't blame him. He'd probably feel the same way. But wars aren't won by feelings. Morrison approaches, looking like he hasn't slept. He probably hasn't. The first batch of jigs arrived from the machine shop overnight. 27 fixtures for wing assembly, 14 for fuselage sections. Carson's team is setting them up now. The instruction manuals? Complete. Every station, every task, every tool. Written at 6th grade reading level with photographic guides. Morrison hands over a thick binder. Ruth helped edit them. Turns out a schoolteacher knows more about clear instruction than the engineers do. Knudsen flips through the manual. Step-by-step procedures. Colour photographs. Diagrams. Tool lists. Safety warnings. Quality checkpoints. Everything a worker needs to assemble a component without needing to understand why it works, just that it does. And the workers? 300 new hires start this morning. Factory jobs are easy to fill these days. Every aircraft plant in the country is desperate for labour. We've got former mechanics, welders, a few ex-teachers, a lot of women whose husbands are overseas. Carson's been running them through training in shifts, basic tool use, safety procedures, how to read the manuals. 3 weeks of training? 2, actually. They're learning faster than we expected. Morrison allows himself a small smile. Turns out when you make the job clear enough, people are pretty capable. At 6 a.m, the day shift arrives. New faces, younger than the craftsmen they're replacing. More women, about 40%, which would have been unthinkable in aircraft manufacturing 2 years ago. They gather at the edge of the empty factory space, uncertain, holding lunch pails and thermoses. They look nervous. They should be. In 8 hours, they're going to start building components for the most advanced bomber in human history. Most of them have never worked in a factory before. Knudsen addresses them from a raised platform. No microphone. He doesn't need one. His voice carries. "Good morning. My name is William Knudsen. I used to build automobiles. Now I'm here to help you build aircraft." He pauses. Some of you are probably wondering if you're qualified for this work. If you're smart enough, skilled enough, experienced enough, let me answer that question. You're not. Confused murmurs ripple through the crowd. You're not qualified because nobody is qualified until they do it. The men who built B-29s before you spent 15 years learning their trade. You have 2 weeks. That's not enough time to become a master craftsman. He lets that sink in. But it's enough time to become a master at following a process, and that's all this job requires. He holds up one of Morrison's instruction manuals. Everything you need to know is in here. Where to put each part, which tool to use, how to check your work. If you can read, you can build a bomber. If you make a mistake, the process will catch it. If you have a question, your supervisor has the answer. And if something doesn't make sense, you stop and ask. The only unacceptable action is guessing. A hand goes up in the crowd. A woman, maybe 30, wearing coveralls that are still creased from the store. "Sir, what if we're not fast enough? I heard the old workers could do this blindfolded." The old workers were brilliant, and they could build 16 aircraft per month. We're going to build 95. He points at the empty factory floor. Not because you're faster than them, because there are more of you, and the process lets you work in parallel. Speed doesn't come from working faster. It comes from eliminating waiting. He gestures to Morrison. Mr. Morrison will assign you to your stations. You'll spend today learning your specific tasks. Just your tasks, nothing else. Tomorrow you'll practice. By Friday, you'll be building components that will fly over Japan. And 6 months from now, when people ask how we won the war, part of the answer will be standing in this room right now. The workers file onto the floor. Morrison and his team guide them to stations. Each position has been marked with coloured tape on the floor. Each workbench has a numbered instruction manual. Each tool has a designated hook with a silhouette showing where it belongs, stolen from Henry Ford's shadowboard system. Knudsen watches a young man, can't be more than 20, probably 4F or he'd be in the army, approach the main spar assembly station. The kid looks terrified, picks up the instruction manual with shaking hands. Step 1. Verify main spar part number matches work order. The kid checks, it matches. He makes a check mark on the instruction sheet. Step 2. Position main spar in assembly fixture. Alignment pins in holes A, B and C. The kid looks at the spar, looks at the fixture. 3 holes, clearly labelled, 3 pins, colour-coded. He lines them up. They slide in. The spar is now held in perfect alignment. Step 3. Verify alignment using laser gauge at positions marked with blue dots. 3 blue dots on the fixture. The kid picks up the laser gauge, which is idiot-proof, green light means good, and checks each position. Green, green, green. He's been working for 3 minutes and he's already accomplished what used to take Kowalski 10 minutes of experienced hand-fitting. Across the floor, the same scene repeats at 30 stations. Workers following instructions, fixtures ensuring accuracy, colour-coded tools preventing mistakes. No craftsmanship required, just literacy and attention to detail. By noon, the first wing rib is installed. It takes 40 minutes, much slower than Morrison's test team, but it's correct. The quality checkpoint confirms it. The worker who installed it, a former grocery clerk named Thomas, looks at his handiwork with something like wonder. By 3 p.m., 3 more ribs are installed, faster this time. 28 minutes, 22, 19. The workers are learning, not through years of experience but through repetition within a system designed to make repetition effective. By 5 p.m., when the shift ends, 6 ribs are installed. It's not fast, not yet, but it's happening, and tomorrow will be faster. Knudsen tours the floor as workers clock out, stops at Thomas's station. "How was your first day building aircraft?" Thomas grins, exhausted. "Sir, this morning I didn't know what a rib was. Now I've installed 3 of them. It's like..." He struggles for words. "It's like following a recipe. If you do each step right, it works." That's exactly right. Knudsen makes a note in his book. "See you tomorrow." May 15th, 1944. 6 weeks later, the transformation is visible from the factory entrance. The floor that was empty in early April now hosts 7 B-29s in various stages of assembly. The sound is different too, more rhythmic, more synchronized. The chaos of craftsmen working independently has been replaced by the orchestrated precision of an assembly line. Morrison's report sits on Knudsen's desk. Average man-hours per aircraft, down to 6,200 from 10,247. Monthly production rate, 37 aircraft from 16. Worker training time, 16 days average from 8 months. Defect rate, 0.3% compared to 0.5% with craftsmen. Process efficiency, 72% compared to 43%. The numbers tell the story. The new method isn't just faster, it's better, more consistent, more scalable, more sustainable. But numbers don't capture everything. Knudsen walks the floor during night shift, stops at a fuselage assembly station where a woman named Dorothy is installing a complex pressurization valve. 6 weeks ago she was a seamstress. Now she's performing a task that used to require a master aviation mechanic. She notices him watching. "Mr. Knudsen, is this correct?" She points to the valve orientation. He checks. It's perfect. "Yes. How did you know?" "The instruction manual shows the valve label should be visible from above. This one was sideways, so I rotated it." She says it matter-of-factly, like it's obvious. It is obvious. But only because Morrison made it obvious, captured that expertise. Valve labels should be visible for maintenance access, and built it into the instructions so that Dorothy doesn't need to know why, just what. "You're doing excellent work," Knudsen tells her. "Thank you, sir. My husband's a bombardier on a B-17 in England. Every time I install something, I think about him up there, hoping the person who built his plane did it right." She returns to work. "So I make sure I do it right." That's the other thing the numbers don't capture. Motivation. These workers aren't craftsmen, but they're not automatons either. They're people with husbands and sons and brothers overseas. Every rivet they set is personal. Every valve they install matters. Knudsen continues his tour. The facility is running 3 shifts now, 24-hour production. The old master craftsmen worked 8-hour days because their expertise was exhausting. These new workers can be rotated, replaced, scaled. The process is tired-proof. He reaches the final assembly bay where completed B-29s undergo testing. A Superfortress gleams under the work lights, every system checked, every component verified. On its nose, someone has chalked, built by Shift C, May 1944. A crew chief, one of the old-timers who stayed, who adapted, approaches. Mr. Knudsen, this one's ready for flight testing. Want to know something interesting? What's that? Took me 30 minutes to do the pre-flight inspection. Usually takes 2 hours. He pats the fuselage. Everything's where it should be. Everything's marked clearly. Everything's consistent. Used to be. Every aircraft was slightly different. Made sense to the craftsmen who built it, but hell for maintenance crews. These new birds, they're identical, like they came from the same mould. They did, Knudsen says. That was the point. The crew chief nods. Well, the boys flying these are going to appreciate it. Easier to repair in the field when everything's standardized, he pauses. I was skeptical, you know. Thought you couldn't build quality aircraft with assembly line methods. I was wrong. Knudsen shakes his hand. You weren't wrong. You were incomplete. Craftsmanship builds quality. Process builds consistency. We needed both. He walks back to his temporary office, sits at the desk, looks at Morrison's production projections for the next 6 months. June, 52 aircraft. July, 68 aircraft. August, 81 aircraft. September, 95 aircraft. 95 B-29s per month from one facility. And Boeing has 3 more plants being retooled right now. By 1945, they'll deliver over 1,000 Superfortresses, enough to firebomb every industrial city in Japan, enough to escort the invasion fleet if it comes to that, enough to make American air superiority not just possible, but inevitable. All because he asked a simple question. Why are you building planes wrong? August 9th, 1945. 11:02 a.m. Nagasaki, Japan. The B-29, Superfortress boxcar, banks away from the mushroom cloud rising 40,000 feet into the sky. Inside, the crew is silent. They've just dropped the second atomic bomb. The war, everyone knows now, is effectively over. Boxcar was built in June 1945 at the Boeing facility in Omaha, Nebraska. Assembly time, 2,847 man-hours. Workers, mostly women and men too young or too old for combat. Training time, 3 weeks average. The aircraft performed flawlessly. 4,000 miles away, William Knudsen sits in a Washington, D.C. office, listening to the radio report. The announcement doesn't mention B-29s, doesn't mention assembly lines or jigs or instruction manuals, just talks about American technological superiority, the atomic bomb, the end of the war. But Knudsen knows the truth. The atomic bomb was brilliant. The B-29 that delivered it was revolutionary. And the manufacturing process that built 3,970 B-29s in 18 months. That was what actually mattered. You can't drop an atomic bomb you can't deliver. Can't deliver it without an aircraft. Can't build the aircraft without a process that scales. Morrison enters. He's been promoted 3 times since April 1944, now oversees production at 4 Boeing facilities. Sir, the numbers came in from all plants. Final tally for B-29 production program. He hands over the report. Knudsen reads, total B-29s produced, 3,970. Average man-hours per aircraft, 1945, 2,960. Total workforce employed, 47,000 workers. Average training time, 19 days. Defect rate, 0.19%. Combat loss rate due to manufacturing defects, 0.03%. Knudsen does the math in his head. At the old rate, 10,247 man-hours per aircraft, limited skilled workforce, they would have produced maybe 600 B-29s by war's end. 600 aircraft to attack an entire nation. Instead, they built nearly 4,000, enough to burn 67 Japanese cities, enough to establish total air supremacy, enough that Japan's military leaders couldn't pretend they had any chance of victory. The old-timers are already saying we got lucky, Morrison says quietly, that the atomic bomb won the war, not production. They're half right. Knudsen closes the report. The atomic bomb ended the war, but production building enough aircraft, enough tanks, enough ships, enough ammunition. Production won it. There's a difference. He thinks about Kowalski, the master craftsman who retired rather than adapt. Knudsen had sent him a letter last month, told him his techniques, his hand-fitting, his alignment expertise, his intuitive understanding of metal stress, had been captured in the fixtures and jigs now used across every Boeing facility. That his knowledge was still building aircraft just through other people's hands. Kowalski never wrote back. What happens now, Morrison asks? The war's over. Do we keep building B-29s? No. The B-29 production line will wind down by year's end. Knudsen stands, walks to the window. Washington, D.C. stretches below, monuments to democracy and dead presidents. But what we learned, that doesn't end. The process doesn't end. What do you mean? Every factory in America just learned they can scale faster than they thought possible, can train workers faster, can standardize processes they thought required expertise. The B-29 was aircraft, but the method? Knudsen turns back. The method works for everything. He's already thinking ahead. After the war, American factories will retool again. Back to automobiles, refrigerators, televisions, but they'll carry forward the lessons learned under wartime pressure. Assembly line techniques refined to their absolute limit. Process engineering elevated to a science. I got a letter last week, Knudsen continues, from a mother in Iowa. Her son was a waist gunner on a B-29, flew 32 missions over Japan, survived, coming home. She wanted to thank the people who built his aircraft. He pulls the letter from his desk drawer. She asked if she could visit the factory, meet the workers who built it. What did you tell her? I told her we built over 3,000 B-29s. Her son's aircraft was number 2,847. I sent her a photograph of the assembly team who worked on that specific production run. 12 people, 8 women, 4 men, combined age, 347 years, combined pre-war aircraft experience, 0. Morrison looks at the photograph. Did she write back? Yes. Knudsen smiles. She said she couldn't believe such ordinary people built something so extraordinary. I wrote back and told her that was the entire point. Extraordinary things shouldn't require extraordinary people. They should require extraordinary processes that ordinary people can execute. He thinks about Dorothy, the former seamstress installing pressurization valves, about Pete, the grocery store manager riveting wing ribs, about Ruth, the schoolteacher who edited the instruction manuals that made it all possible, about 300 people who walked into a factory knowing nothing and walked out having built weapons that changed history. You know what the real revolution was? Knudsen asks. Not the B-29's technology, not even the production rate. It was proving that expertise is transferable. That knowledge doesn't have to die with the people who hold it. That we can capture what masters know and distribute it to everyone. Morrison nods slowly. The craftsmen thought we were replacing them. We were, but not with machines, with systems. Knudsen picks up his hat, prepares to leave. Machines replace labour. Systems replace expertise. There's a difference. Labour is about effort. Expertise is about knowledge. And knowledge, properly captured and systematized, becomes accessible to anyone willing to learn. They walk out of the office together, through hallways filled with men in uniform planning the occupation of Japan, planning the post-war world, planning everything except the thing that already changed, how things get made. Where to now? Morrison asks. Detroit. Ford wants help retooling for civilian production. Chrysler's talking about a new manufacturing process for home appliances. General Motors is considering. He pauses. Everything. They want help with everything. Because of the B-29. Because of what the B-29 proved. That the impossible just requires the right process. September 2nd, 1945. Tokyo Bay. The Japanese sign the surrender documents aboard the USS Missouri. Above them, 462 B-29 Superfortresses fly in formation. A demonstration of the force that brought the Empire to its knees. The sky is darkened by aluminum wings. Each of those aircraft represents 2,960 man-hours of labour, built by workers trained in 3 weeks, assembled using processes developed in 6 months, delivered in quantities that 18 months earlier were considered fantasy. In the crowd aboard the Missouri, a young Army Air Force intelligence officer named Peter Drucker, watches the B-29s pass overhead. After the war, he'll write about this moment, about how America won not through superior strategy or braver soldiers, but through superior manufacturing. How the real weapon wasn't the atomic bomb, it was the ability to produce 3,970 aircraft capable of delivering it. He'll write about the transformation from craft to process, from artisan production to systematic manufacturing, from building things one at a time to building systems that build things. He'll call it the management revolution, and he'll trace it back to a moment in February 1944 when an automobile engineer walked into an aircraft factory and asked the simplest, most devastating question possible: why are you doing it wrong? March 15th, 1948, Detroit, Michigan. William Knudsen, 73 years old now, officially retired but busier than ever, gives a speech at the Society of Automotive Engineers. The audience is filled with the men who'll build post-war America: factory managers, industrial engineers, production planners. They want to know the secret. How did America outproduce the entire Axis powers combined? How did factories that had never built a tank produce 88,000 Sherman tanks? How did aircraft plants that barely existed in 1940 deliver 300,000 aircraft by 1945? Knudsen's answer is simple. We stopped treating manufacturing like art and started treating it like science. Art requires talent, science requires process, and process, properly designed, is accessible to everyone. He shows them photographs from Boeing Plant 2, the before and after, master craftsmen working individually in 1943, assembly line teams working systematically in 1945, same aircraft, 6 times faster production, half the defects. The craftsmen weren't wrong, he explains, they were magnificent. But magnificence doesn't scale. Process scales. And in war, scale decides everything. An engineer in the audience raises his hand. Mr. Knudsen, some say we won because we had more resources, more steel, more aluminum, more oil, that the Axis never had a chance against American industrial capacity. That's backwards, Knudsen replies. We had industrial capacity because we had processes that could scale to use it. Germany had skilled labour, better trained than ours, honestly. Japan had dedicated workers willing to die for production. But they both tried to scale craftsmanship. You can't scale craftsmanship. You can only scale process. He pauses, looks at the young faces in the audience, men who'll design the factories that build 1950s America. That created the post-war boom, that established American manufacturing dominance for the next 30 years. The lesson from the war isn't that we had better technology. We didn't. German engineering was often superior. The lesson isn't that we had braver soldiers. The Japanese fought with incredible courage. The lesson is simple. We had better processes, and processes, unlike courage or technology, can be taught, transferred and scaled indefinitely. That, he concludes, is how you change the world. Not by building better things, by building better ways to build things. The audience applauds, but Knudsen is already thinking about the next revolution. Computers are coming. Primitive now, but promising. Television manufacturing, jet aircraft. Eventually he suspects things he can't even imagine. But whatever comes next, the principle remains. Complexity doesn't require craft, it requires process. And process, properly designed, makes the impossible routine. February 14th, 1964. 20 years to the day since Knudsen walked into Boeing Plant 2. William Knudsen has been dead for 13 years, but his legacy is everywhere. The interstate highway system, built using mass production techniques for concrete and steel, suburban housing developments, identical homes assembled from prefabricated components, television sets in 40 million homes built on assembly lines that would have seemed impossible in 1940. At Boeing, a new generation of engineers is designing the 747 jumbo jet. It's impossibly large. Will carry 400 passengers, requires revolutionary manufacturing techniques. A young production engineer named Davis is leading the planning team. He's studying the old files from the B-29 program, reading reports written by someone named Morrison about fixture design and interchangeable components. Reading notes in the margins, written in neat handwriting signed WK. Davis doesn't know who WK was, doesn't know about the test in March 1944, or the transformation that followed, just knows that someone 20 years ago figured out how to build complex aircraft with simple processes. He's going to use the same principles for the 747, break complexity into simple steps, capture expertise in fixtures and instructions, train workers in weeks, not years, scale through process, not craft. It'll work. The 747 will revolutionize air travel, and Davis will never know he's following a path laid down by a Danish immigrant who asked obvious questions nobody else thought to ask. That's the nature of real revolution. It becomes so normal, so fundamental, so obvious that eventually nobody remembers it was ever revolutionary. In 1944, building a bomber with assembly line techniques seemed impossible. By 1964, building anything any other way seems absurd. William Knudsen changed manufacturing forever, and his reward is that nobody remembers he did it, except in the numbers. 3,970 B-29 Superfortresses, built in 18 months, delivered by workers trained in 3 weeks, flying proof that the impossible just requires asking the right question, why are we doing it wrong, and having the courage to hear the answer.